Hello everybody. The topic for today's discussion is scheduling policies. So what is scheduling? So what is the need for scheduling? First, the need for scheduling is, so there will be a processor in your computer and there will be a lot of process waiting to get this processor. So for example, these processes will be maybe P0, P1, P2, etc. up to Pn. All these processes will be waiting in a ready queue. They are ready and they are waiting for the processor. So there should be a policy that should select which process will run or which process will get the CPU scheduler. So for this there are a number of policies. So scheduling policy is nothing but a policy by which you are selecting the right process to run or the right process which will get the CPU at the time. So there are a number of policies. So we will see the policies are, first one is first in first out, the next one is last in first out, third one is you can have shortest job first, then it will be a priority scheduling, then the last one is a round robin scheduling. So we will discuss all these 5 scheduling policies. First one is first in first out. What is first in first out? Consider you have 5 processes arriving like this: process 0, P1, P2, P3, P4. All these 5 processes arrive in the same order, maybe in this order: P0, P1, P2, P3, P4, and they will have different times. Maybe this requires 5 milliseconds, 4, 2, 1, 0.2 milliseconds. Then the first process that will run is P0 will run. Second, because it is first in first out, first process, since P0 has arrived first, P0 will execute first, then P1 will execute, then P2 will execute, then P3, then P4. So this is how a first in first out strategy executes. So suppose if you are using a last in first out strategy, last in first out strategy means suppose these 4 processes arrive at the same time and the last one which has come here is P4, then P3, then P2, then P1, then P0. So what is the problem with this first in first out strategy is that suppose you have the last process maybe P0 to Pn and the n process requires only 1 milliseconds to complete and the first process requires 100 milliseconds to complete, and in between you have number of processes which may require 50 milliseconds in total. This last process has to wait to complete its 1 millisecond work. It has to wait for 150 milliseconds. So indefinitely it is going to wait, or it is waiting for 150 milliseconds to complete a 1 millisecond process. So this is a problem in this first in first out strategy. So to prevent that, we are going for a shortest job first scheduling. What is shortest job first? Suppose if you have 3 processes, P0, P1, P2, and P0 job requires 10 milliseconds to complete, P1 requires 2 milliseconds, and P2 requires 1 millisecond. First I will run the first one that gets the CPU is P2. That will once it is completed, P1 will run. Once it is completed, then the remaining shortest job is P0. Then P0 will run. This is how a shortest job scheduling algorithm works. Then the next one is maybe we'll go for priority scheduling. So what is priority scheduling? Priority scheduling works like this. You have a process, you have time, then you will have, so this time is called as burst time. That is the time required to complete a process. Burst time is the time required to complete a process. So priority will be, for example, if I give the priority 1 and this is 2 and 3, means you have 3 processes, you have time, you have priority. So the highest priority is 1 and it is given to process P1. So first P1 will complete, then P2 will complete because it has the second priority, then P3 will complete. Conversely, if this is the first priority process, this P0 will complete first. Then if it is the last priority process, it will complete. And if it is a second priority process, it will come. So based on priority, the processes will run. The next one is round-robin scheduling. So what is round-robin scheduling? See, round-robin scheduling is nothing but you have a process which will be allocated the CPU only for a limited amount of time. So how this will happen? You have two types of way to do this. First one is preemptive scheduling and non-preemptive scheduling. So what is preemptive scheduling? So consider I am allocating the CPU to a process, and maybe a process 1, and it requires 100 milliseconds to complete. And if I allow the CPU, if I allow this process to run without any disturbance, and it will complete till it is complete, it will run until its completion, then it is called as non-preemptive scheduling. A process will run without any disturbance, and other process may wait. It may lead to starvation for other process, but the process which gets the CPU will run till it is completed. That is called as non-preemptive scheduling. And what is preemptive scheduling? So preemptive scheduling in the sense, I have a CPU, I will allocate to a process, and that process will be allocated to a CPU for a limited amount of time. For example, if you have a process and it requires 100 milliseconds to complete this work, and if the time schedule I have given is 5 milliseconds, so process P1 will start, it will run from time 1 to 5, so it will run. After that, the CPU will be forcefully removed from the process. So process P1, the time from 0 to 100, it requires all this time. So once it has reached 5, CPU will be removed and given to some other process. So that is called as preemptive schedule. That is, you have a time limit. In that time limit, you have to work. Then when your next schedule comes, or when your time comes in the next time, you can start from the 5th to 10, because your time limit is 5 milliseconds. Then other process will run. Then you have to start from 11 to 15. Similarly, so the CPU will be swapped in and swapped out until you complete. So without any disturbance, if you are going to use the CPU, that is called as non-preemptive scheduling. And if the CPU is given to a process only for a limited amount of time, then it is called as preemptive scheduling. So we will discuss all these schedulings with the help of an example. Consider I have a process and I have a burst time, process P1, process P2 and process P3, and they have burst time of 24, 3 and 3. First, to check how this works, we have to use a chart called as Gantt chart, and we'll discuss how FIFO works, that is first in first out works. So first process to come in is P1, so it arrives at time 1 and it arrives at time 0 and it requires 24 seconds to complete. So 1, 2, 3, 4 till 24 it will complete. So P1 completes at 24, then P2 it requires 3, 24, 25, 26, 27. So it completes at until 27, and P3 28, 29 and 30. So now you can see that P1 will start at 0, it runs till 24. P3, so P3 will start, maybe will give us 1, it runs till 24, it requires 24 times. So I can see here, you can listen. So we have to calculate the waiting time. So for P1, it does not wait for any time. When it arrives, it gets the CPU. So P1 waiting time is 0. P2 waits till 24. So waiting time of P2 is 24. And P3 waits till 27. And you get the answer. So what is average waiting time? Average waiting time is P1 waiting time plus P2 waiting time plus P3 waiting time divided by number of processes. So it will be 0 plus 24 plus 27 divided by 3. So you'll get the answer. Then next one is turnaround time. So what is turnaround time? See, when does this process gets completed? P1 turnaround time is the time at which the process gets completed. So P1 gets completed at, turnaround time for P1 is 24, P2 is 27 and P3 is 30. So average turnaround time is 24 plus 27 plus 30 divided by 3. This is how you calculate the waiting time and turnaround time. Now we will see the Gantt charts for other process like SJF. So you can see here you have 3 processes, P1, P2, P3. The shortest job has the burst time of 3. So 2 processes have the burst time of 3. So when you have 2 processes having the same burst time, you can select from that 2 who came first, that is P2. So first P2 will run. P2 will start from time 1, 2, 3, 1, 2 and 3. 3 times it will be completed, 1, 2 and 3. So we'll put a 0 here. So time 1, time 2 and time 3. So it gets completed at time 3. Then P3 comes 3, 4, 5 and 6. Till 6 it will be completed. The next one is P1. It completes at 30. Now you can see that P2 comes first, P3 comes next, because this type of scheduling is shortest job first. Then here you have to, using the same procedure which I have explained already, you have to find the waiting time and turnaround time. So waiting time for P2 will be reduced now because it requires 0 time. P3 requires only 3 seconds, wherein in the first in first out it has to wait for 24 and 27 seconds respectively. Now if you go for a priority scheduling, I will give a priority here. So priority can be 0, 1 and 2. Then if priority is given like this, first P3 will run, then P2 will run, then P1 will run. That means first 0 to 3, then 6, then 30. Similar thing, but P3 has run because it has the highest priority. Same problem if you work for shortest job, round robin scheduling. So the round robin scheduling, maybe the time limit is 6 milliseconds, and first the process P1 arrives. It starts from 0, it goes to 6. Now the CPU is forcefully removed and given to process P2. Process P2 has only 3 seconds. So 7, 8 and 9. Till 9 it will complete. It is completed. Then process P3 goes. Process P3 starts from here. 10, 11 and 12. Till 12 it will be completed. So these 2 processes are completed. Only this process 6 is complete. Remaining you have 18 to complete. Now process P1 starts. It will work for 6 times. Then CPU is again removed. So till 18. Then when no process is there, again P1 gets. So P1 will get till 24. Again CPU is removed. Then again, since no process is there, again P1 is allocated till 30 it will work. This is how. So process P2 waits till 6 seconds. Process P3 waits till 9 seconds. And the process P0 waits. So the waiting time will vary. It waits for 0 seconds first. Then it waits 6 to 12. It is waiting for 6 seconds. So it changes. So here, since in first in first out we have indefinite waiting, but here we have solved that problem by means of round robin scheduling. So in this video lecture we have discussed about what is scheduling and what is the need for scheduling. The need for scheduling is you have to select which process will run or which process will get the CPU first. So for that we have discussed 5 strategies. First one is first in first out. Then we have discussed about last in first out, shortest job first. Then we have discussed about priority scheduling, and then we have discussed about round robin scheduling. First in first out, the process which runs first, or with the process which comes first, will be running first, then shortest job first. The problem in first in first out scheduling was that when a process which comes first has a large burst time, the smaller process has to wait indefinitely. So to prevent that, we have gone for shortest job scheduling. So in shortest job scheduling, the shortest job which requires, or among all the jobs, the job which is very short will be made to run first. Then we have seen about the priority scheduling. After priority scheduling, we have discussed about round robin scheduling, where a time limit is given. Only in that time limit the process is allowed to execute. Once the time limit is exceeded, the next process will be given the chance. So here the race condition is minimized. So by discussing all these four things, we should have understood what is scheduling policy and what is the need for scheduling. Hope you understood the lecture. Thank you.